Okay, good morning, good afternoon, good evening, depending where you are around the world. Welcome to another RISSB Masterclass, and today it's around Australian rail innovation, testing autonomous vehicles on the ARC infrastructure network. Firstly, I'd like to acknowledge the traditional owners of the lands where we meet today, and for me, that's the Kaurna people of the Adelaide Plains, and to recognise their elders past, present and emerging, and to acknowledge any Aboriginal or Torres Strait Islander people who might be with us today. As I mentioned, today's talk is about testing autonomous wagons on the ARC network. I was fortunate enough to be over there, I think it was early this year, late last year, to see the trial. It was quite, it was amazing just to see this wagon take off. And it reminded me many years ago, I was involved in a project at an automated bogie exchange. Which had a similar looking wagon, except it was dirty, noisy, diesel powered thing that, as I recall, wasn't very reliable at all, which I'm sure the parallel systems equipment is much different. So we've got two presenters today. Firstly, Mary John. And Mary, we thank you so much. I understand it's 6 p.m. Los Angeles time, so on Sunday evening. So hopefully you can get this out the way and then go and enjoy a nice meal. Mary has spent her career working in the built environment, infrastructure environment, advising local and national organisations on policy, planning, and infrastructure improvements. And she spent the last 2 years with Parallel Systems, growing customer and partner relationships to bring innovative rail technology to market. And Simon Gilders is Head of Development, ARC Infrastructure, is responsible for ARC's growth and innovation strategies. He's over 20 years experience developing opportunities within rail and logistics businesses across Western Australia. So firstly, I'll hand over to Mary. I think Mary's going to do the first part of the presentation, then followed by Simon. At the end, we'll have the opportunity to go through some of the questions. And of course, for those online, please just put your questions in the chat and we'll get to at the end of the presentation. So if I could, Mary, I'll hand over to you. Thank you.
Great. Thank you so much, Damien. We are so excited to be here today. I'm going to share my screen and we will get started here. So I just want to say thank you again. We're looking forward to talking about our technology here today. And, Parallel Systems has had the opportunity to be working in the Australian market. A vehicle landed in September of 2023. I myself had the chance to head out to Perth, meet with ARC Infrastructure in December of 2023. And we're just super excited about the Australian market. So I'll go through a presentation here about our technology, and then Simon will talk about how that technology is operating in Australia. So the first thing that I'll do is introduce you to our team. Parallel Systems was founded in 2020 and is a venture-backed company. We're based in Los Angeles, and we're about 100 team members strong, covering skill sets anywhere from software developers to mechanical engineers and locomotive engineers. We're all dedicated to reducing the emissions from the global freight supply chain. That's why we work for Parallel Systems. Parallel Systems is creating the tools to convert freight from trucking to rail, enabling the rail industry to serve more markets. We're building autonomous, battery electric freight rail vehicles and the tools that integrate this service into railroads to enable railroads to serve markets that they haven't typically been able to compete with from either a service quality or a cost perspective. We believe that our technology will allow railroads to expand to provide intermodal service and customers a more flexible zero emissions option to move freight. So diving into that a little bit deeper, our teams are developing three things as a business. The first are self-propelled battery electric freight rail vehicles. One vehicle carries one intermodal shipping container. The second, and perhaps the most important, are the management systems that integrate into existing train control and dispatching systems of railroads, and then the interfaces that ensure a smooth control experience in terminal environments. These are the things that are going to allow us to interoperate and coexist with conventional freight rail operations. And finally, we're developing new terminal concepts that these vehicles and these systems enable. The continuous flow of containers through terminals results in greater asset utilization and smaller footprints, making it possible to site terminals closer to or even at customer locations, reducing and eliminating that last mile of transit. Taking a look at the vehicle specifications, we're building vehicles that are targeting the needs of the rail industry with ranges, speeds, and carrying capacity that are capable of the target services that are competing with trucks. We've taken a novel approach to our braking solution that enables immediate braking responses and automatically adjusts to apply the appropriate braking forces for the payload. As a result, our testing demonstrates a stopping distance much shorter than that of a conventional freight train. Our vehicles are rarely envisioned to move through the rail network as single containers. They have the ability to route themselves and break out to final customer destinations, but they'll move through the network in platoons of 10 to 50 cars. Platooning, or what we're calling the movement of multiple vehicles together, is a better use of rail network capacity, and it results in energy efficiencies as the follower vehicles share the work of the aerodynamic drag forces on that lead container over the entire platoon. In a platoon formation, these vehicles are basically drafting off of each other, experiencing less collective drag. And then finally, we envision charging to take place where these vehicles naturally dwell, during the loading and unloading process in terminals. These vehicles are capable of fully charging in 1 to 2 hours, depending on the use case. To enable the value of parallel services, reimagining what a terminal could look like is key. We've coined the phrase the micro-terminal, and this is a low-cost solution placed in an industrial district or close to a cluster of customers using minimal infrastructure to unload boxes. This could be as simple as a reach stacker and a parking lot, and it's used to manage seasonal demand. We're really asking the question, how low can we get the capital expense to get boxes on and off rail? We're also exploring options to eliminate the first and last mile entirely, with ports where our rail vehicles could go directly under the key crane or right up to a warehouse dock like a truck does today. Once in service, there are a variety of uses. The first is what we really think about as an expanded line haul service. Parallel systems technology can expand line haul services by connecting intermodal rail terminals and ports and city-to-city pairs that haven't previously been served by intermodal rail. These line hauls are less than 1,000 kilometers, and they're connecting origin and destination points that have existing infrastructure at one end or another, but for whatever reason are being bypassed by truck. Parallel systems unit economics allows rail service to be offered on these shorter haul routes at a price competitive to trucking that currently serves those markets. The second use case that we look at is a port shuttle. And this is the case that we're exploring with ARC Infrastructure, and Simon is going to tell you a little bit about later in this presentation. Parallel systems vehicles can route containers into and out of ports, reducing the amount of time a container dwells on congested port real estate. Containers would be shuttled to intermodal rail terminals in metro areas, reducing port drayage activity and those associated emissions. The vehicles could be dedicated assets to that short haul route, and they can even be used to move containers to and from stacks on dock. And then finally, we think about this idea of going direct to a customer, which can be used in combination with any of the first two services. We can deliver containers directly to warehouse docks or micro terminals developed in industrial districts, giving customers direct access to rail freight transportation. Vehicles route directly to the customer location, unloading single or multiple containers at one time, very similar to how a truck interacts with warehouse loading docks today. The service eliminates lift and drayage costs, and cargo weights can be increased. So to summarize our service, what we're really trying to do as a business, we're trying to improve the quality and the frequency of intermodal rail service with technology that competes with trucking unit economics and then lowers the capital thresholds to start opening these services, particularly around the terminal environments. If we can bring all those things together, we ultimately believe that we're making everyone in the supply chain more efficient in the process of moving freight. So I've talked a lot about efficiency. I also want to talk about decarbonization benefits as well. If we really want to make an impact on the carbon emissions in the freight industry, the case is pretty clear that we need to shift freight from truck to rail. Rail has inherent energy efficiencies over trucking due to the lower rolling resistance of steel wheel on rail as compared to rubber tire on asphalt. You can electrify trucks and you can make them more aerodynamic, but they will still consume significantly more energy to move the same amount of freight. And in the US, where we're based, our energy grid isn't clean. So electric trucks are actually comparable in emissions to that of a diesel freight train. And no matter where you are in the world, parallels rail vehicles use about 75% less energy per mile than traditional semi-trucks. And its energy efficient battery electric powertrain produces 90% less CO2 per mile than a traditional truck when it's charged using average power grid electricity. And so what we're really saying is that the combination of both autonomy and electrification on rail allows us to achieve dramatically lower emissions today to help impact the emissions of the entire supply chain. We then kind of move into the safety case here. We believe the system has improved safety benefits as well as these kind of carbon and efficiency benefits as well. We have what we call a perception system. And these are cameras on the front of our vehicles that are able to identify hazards in the rail environment, recognize those hazards, and make decisions. I'll talk a little bit more about the perception system later in this presentation, but what's really important here is that we're bringing object identification into the same range as our stopping distance. So if the vehicle sees a hazard and needs to stop, the vehicle is actually capable of doing that with its braking system. So getting into a little bit more detail about how this actually works. Even though kind of every railroad in the world has its own set of operating rules and dispatching technology, our architecture and concept of operations allows us to efficiently onboard railroads and then even interoperate across different railroads. We have a centralized fleet-wide control system that sets the vehicle's speed and position on the track. This fleet control system then also interfaces with the infrastructure and the software running in the host railroad's back office. By keeping parallel software in sync with the train control systems operated by the host railroad, we keep the vehicles moving through the network in accordance with all dispatcher directives. The vehicles stay in sync with the parallel control software because the vehicles are continuously transmitting information on the location and the vehicle performance and the vehicle health using GPS, cell networks, and Wi-Fi, depending on where you are in the network. While planned movements are determined by the host railroad dispatcher, the vehicle is also using that onboard perception sensors that continuously sense for hazards on the rail. When a hazard is sensed, the vehicle's onboard software brings that vehicle to a stop. And when unplanned stops do occur, the host railroad's personnel is able to assess the situation and then make decisions about how best to restore service and involving local personnel if required. So going a little bit more into that perception system, I have a video here. It takes a few minutes, it takes a couple seconds to load and catch up here, but what you're seeing, make sure it's fully playing, what you're seeing here is a set of data that we're collecting in the rail environment to help train our perception system. The perception system is helping us respond to the many challenges of a complex rail environment. The system senses the world around it using a suite of onboard sensors and predicting the type and position and future trajectory of each object relative to the track. And the perception system can anticipate future interactions between the vehicle and those hazards. And then it works with the fleet control system on the vehicles, and it determines the safest response to the hazard that minimizes route disruption. So, for example, if an object is fouling the track, the vehicle will stop. This system, combined with the integration with a railroad's dispatch and train control system, provides a multi-layered approach to safety. And to kind of come back to the video that we were just watching, this is the set of data that we're collecting for real-world data and the types of hazards experienced in the rail environment that help train this system to identify hazards and then make the appropriate decisions. So we're working on bringing these concepts to life with Genesee and Wyoming on 2 of their railroads in Georgia and the US. Genesee and Wyoming has filed a petition with our regulatory body, the Federal Railroad Administration, to pilot Parallel's zero-emission rail freight technology on portions of their rail line. And we're going through that approval process right now. If approved, we have a multi-phase pilot that would begin this year, and it's overseen by our regulatory body, G&W, and Parallel Systems, allowing us to demonstrate our technology in a field setting while kind of carefully managing the pilot so that it's operated in a safe and controlled manner. And we're also working with our partners, our infrastructure, who you'll hear from next, with our vehicle in Australia and working through that regulatory process as well. So I want to kind of end my time here in this presentation by sharing some videos here of our vehicle generation that is going out to our customer pilots, both in Australia and the US. What you're seeing here is our 2nd generation vehicle. This is still very much a prototype. It is technology that's capable of carrying customer freight. It'll go out into our pilots, but we're learning and growing and understanding how this vehicle performs in real-world rail environments. We'll take all of that learning and we'll bake that into a future production vehicle that will be available in about the 2026 timeframe. We have a 3-mile stretch of track in California, about 60 miles north of Los Angeles, where we're based, where we do all of our integration and testing. And that's where you're actually seeing these vehicles in these videos. This video is demonstrating some of those concepts that I talked about here around platooning and the connection between the sensors and the systems on our vehicle and our back office and a railroad back office. I'll pause here while this video plays out, and then I have one more video that I'll show to end the presentation. Okay, the next thing that I'll show, and this stops, is a video of our most recent technology advancement. So I talked about this concept of platooning earlier in the presentation, and platooning is the movement of multiple vehicles through the network together. We see some real benefits to platooning. It's, as you're traveling through mainline, you make better use of available network capacity if you're moving, multiple vehicles at a time. We also see some tremendous energy benefits where the lead vehicle that's experiencing aerodynamic drag shares that work with other vehicles because they are pushing from behind. And this concept was largely a concept until the end of this year. The end of 2023. We're in 2024 now. The end of 2023, where we began testing this platooning concept at our test site. And so what's happening here is this lead vehicle is being commanded by that train control and dispatch system, and it knows where it's going. It knows it's going from point A to point B. And the follower vehicle knows that it's a follower vehicle. It's still communicating back into that centralized fleet control system, but its primary method of communicating in this platoon is actually through the bumper system. And so in this video, you can see that our vehicles don't have couplers. They have a bumper. It's a spring-loaded bumper on either end, and there are force sensors in that bumper. And so the follower vehicle knows that it needs to press on the lead vehicle with a certain amount of force. And when that lead vehicle decides to slow down, that force increases, and the follower vehicle knows to apply its brakes so that it's maintaining that constant set point. And the same applies when that lead vehicle accelerates. That force lessens, and that follower vehicle, moves forward. And so this concept of being able to demonstrate the ability to kind of self-sort and split and route freight to end customer destinations is something that we've been able to prove out in real life in the last couple of months here. So I will end with that kind of exciting technology demonstration. Hopefully that came through on video. This is also available on our website through a press release. I will stop sharing my screen and I will turn it over to our partners, ARC Infrastructure and Simon, to talk a little bit about this technology in your region.
Yeah, look, thanks, Mary. And rookie team's mistake, I was on mute there just at the beginning. Morning, everybody. At least it's morning here in Perth. Afternoon, obviously on the East Coast. And Mary, I expect you are now starting to look towards where the kitchen table is, where your dinner's going to be turning up pretty soon. I'm really excited to talk about the project that we've got at ARC as well, and the partnership that we've got with Parallel Systems. We've been working with Parallel now for at least a couple of years, and through a first phase, getting a wagon over here in Western Australia, but now a number of phases coming up around integration with all of our systems. So look, I've got a few slides, not too many, but just a few slides to go through the Western Australian project that we're working on. And I'll start with a really kind of, most people will know this, but just a quick introduction to ARC. As most people will know, ARC is the operator of the state's freight rail network here in Western Australia. That's 5,500 kilometres in the southwest, connecting with 5 ports. It's an open access railway, lots of different commodities and customers operating on the railway, iron ore, grain, bauxite, alumina, nickel, and of course container freight, and container freight that comes from the East Coast across the Nullarbor, but also, and in the context of the discussion we're having today, the container freight that comes in through the port of Fremantle. Currently, there's around about 800,000 containers that move through Fremantle Port every year. And 20% of those containers move by rail from Fremantle Port to the industrial precincts around Perth. That 20% that's the highest rail share in the country, but it's still there's still 80% there that's moving by road. We've been, over the last number of years at ARC, really pushing to grow that rail share above 20%. We'd love to get to 30% and even beyond. And lots of support from the state government. Lots of investment in intermodal terminals, which we'll talk about in a little bit as well. And then the wagon concept that we're going to talk about is kind of another way of really growing that rail share beyond 20%. So the other thing happening in Western Australia is that the container port at Fremantle is moving to Kwinana, which is only a little bit further south. And that project's called Westport. The Westport, or the container terminal opportunity, it's a greenfield port, and there's not too many times in our lifetimes that we'll have a greenfield port developed at our doorstep. So we see that as a really kind of obvious and exciting opportunity to do something really different when it comes to rail. And this is where the idea of an autonomous wagon kind of began to develop and evolve, and an idea of putting rail in a priority position to road when it comes to moving containers from the port into the inland industrial precincts. So we began developing the concept of an autonomous wagon around about 2020, 2021. We began to really kind of flesh it out. In the image that you can see there is some of our early kind of design concepts. And as we began to share this with Westport, we introduced the idea of rail that could go directly underneath the quay crane at the new port. And in doing so, containers can come straight off the vessel and then move immediately into inland intermodal terminals. And straight away, that creates a number of really significant benefits. The first one, obviously, is the time benefit. You've got a container that is moving, an import container that's moving straight off the vessel on day zero straight to an inland intermodal terminal, rather than having to dwell on the port and then kind of find its way onto a traditional long train. The lack of dwell time on the port as well goes directly to kind of port footprint. And when it comes to a new port, the capital cost of developing a new port. So by moving the container directly away means that from a state government perspective, the size of the new port either doesn't need to be as big, or more, if it has to, for other reasons, remain at the same footprint, then there are other uses for that port land that having the rail directly under the quay cranes introduces. It's not critical that the rail goes under the quay crane. Rail can still operate in a traditional sense behind the container stacks, but the autonomous wagon, as opposed to a traditional long train, has a much smaller curve radius and can really bend around and get underneath the quay cranes. Not that different to a truck. So that opportunity from a constrained footprint perspective really opens up with the wagon. Mary spoke before, and it's no different over here in Western Australia. An individual wagon, kind of as you come away from the port, opens the opportunity for micro terminals. We've got a couple of locations in the Western Australian landscape where a small intermodal terminal, a micro terminal, would be perfect, where there are areas of high container catchment, but very, very difficult to construct a traditional long siding for various different reasons. So a micro terminal really opens up those catchments to rail and goes along to increase the rail share. So we've been working on this concept with Westport since the 2020s. In 2021, 22, we built it into a full concept of operations for the entire Westport supply chain, from port all the way to inland intermodal terminals. And then through 2021, 22, Westport itself, through a number of its studies, the landside logistics opportunity study specifically, looked carefully at the wagon and other opportunities and ranked the autonomous wagon concept as one of the highest kind of opportunities that it wanted to look at. And now, as we move into the future phases of Westport, it's being embedded in the innovation strategy as part of its business case. So that kind of took us through into 2021, where we first became aware of parallel systems, and it was pretty quickly became obvious to us that our two concepts were remarkably similar. We began talking with Parallel in 2021. At that point, Parallel were only just kind of beginning to become visible in the market. But as we looked at their concept, we looked at what we were thinking and developing over here in Western Australia. There was an obvious partnership, so we enshrined that partnership in 2022, and then kind of it all came together during 2023, where Parallel's first Mark II vehicle was developed, and in September or August last year, September, found its way over to Perth. And during the second half of last year, we reassembled the vehicle and began running a series of trials and commissioning on our ARC network at the Kenwick Rail Freight Facility, which is adjacent to the new intermodal terminal that begins operating this year. So that's the first autonomous wagon, certainly the first autonomous wagon in Australia. For Parallel, I think Mary can talk about this later, but I think Parallel are up to 4 or 5 of these vehicles now. After the first one came over here with their other partners. But the first vehicle over here, and importantly, it gives us the opportunity and the ability to begin kind of testing the vehicle in anger and beginning to work through some of the critical elements that we'll need to have in place before this vehicle can operate in a commercial sense. The safety regulation, the accreditation piece is a really big part of having the wagon over here. We've already begun quite a detailed journey with ONSA, the National Rails Regulator, around getting approval to operate the wagon in the yard and getting approval to begin operating the wagon on the main line in different kind of controlled settings. So having the wagon here is really important as we begin to prove up that safety case here in Australia. I think most people will agree the idea of autonomous vehicles in a rail sense feels like an easier thing to solve than an autonomous vehicle on a road. In rail, we've got a train control system that controls where all other vehicles are on the network. So it feels like an easier problem to solve, but nonetheless, SONSA and ARC are working through exactly what that means and what the steps are to manage that safety case and to ultimately get accreditation to run this vehicle and a fleet of these vehicles in due course on the ARC network. In December last year, and Damien spoke about this at the beginning, we did begin some public demonstrations. We had the Deputy Premier there, you can see in the top right photograph, together with Matt Saul, the CEO of Parallel, and Murray Cook, the CEO of ARC, conducting the very first public demonstrations in Australia of the wagon. And even as late as last week, we've been following up with a number of other demonstrations. And there's a lot of excitement that is growing here in Western Australia, but also many people from the east have been across and seen it. So this is my last slide, and just a bit of a look ahead to what's next. And you'll see on the heading there, Hyver Rail. This is new. Hyver Rail is the name that ARC has given to the concept, and you'll hear us now beginning to talk about the wagon as Hyver Rail. It's a name mainly to distinguish it from ARC in terms of the rail, the below rail operator. It's a name that kind of goes to the wagon concept and the idea of a fleet of wagons operating to and from port. Hyver kind of evolved out of the concept of bees that are moving backwards and forwards from a hive, and that's what we can see how these wagons will operate in a port shuttle sense. And then in terms of what are we working on from here, Mary spoke a fair bit about an integration with train control and how the parallel systems technology interfaces, and this is a really critical thing in our minds. And especially in Australia, where we don't have vertically integrated railways, train control which manages the movement of all the wagons and all the trains that are on the network. The control of parallel vehicles or autonomous wagons on the network, and that integration is an important, in fact, a critical piece to get right. And that's exactly what Parallel and ARC are beginning to work on now through 2024. Now that we've got the prototype over here. Safety I've spoken about already. Safety is definitely a big piece, and we've got a number of kind of goals and milestones that we're working through with ONSA as well as with Parallel and ARC to kind of continue to prove the safety case, and in a sensible and safe and incremental sense begin to kind of overlay additional complexities and really test that safety case. And then, of course, commercial opportunities. Westport is a mid-2030s development. It's got a little way to go before that happens. So we are already beginning to look at other commercial opportunities that exist both in Western Australia on ARC's network, but also around the country. So that those will begin, and Mary spoke about 2026 as being the point where we can see a commercial wagon being ready for deployment. That kind of maps really well with how the Australian landscape is beginning to assess these vehicles. So, Damien, I'm done there with that presentation. I'm going to try to share a video now, which might just take me a minute to get right. And Damien, this is a 2-minute video which I'll play now, and then perhaps that's a good time for us to hand the control back to you.
No problems at all. Great. Thank you, Simon. Now, as you'd expect, there's more than one or two questions. I think what interested me when I first, when I got the invite to come and have a look at the launch was, hey, here's an infrastructure owner interested in above rail innovation. So that was, your innovation takes all forms, including thinking outside the traditional box of infrastructure owners. So that was of interest to me. And then, of course, its application, thinking through the traditional rail view of the world, you'd think, well, traditionally rail efficiencies build on trains being bigger, not smaller, but there's horses for courses, obviously, particularly in a terminal and portside environment where big trains taking up quayside access is counter to productivity from a port's perspective. So it's sort of picking up not just the traditional rail view of the world, but all those other angles as well. So there's a few questions here which you might expect we'll be questioning some things, but if I can start. I can see, this is an I, someone can see this solution working very well to support the inland port concepts, but most ports are located in city areas where the tracks are shared with other passenger and freight trains. What are some of the challenges integrating with existing rail traffic, or is this solution more suitable with a dedicated track allocated for autonomous wagon operations?
I can take that one if you like, Mary. I think the question's spot on, and something that I think the wagon presents solutions on both a shared passenger freight network, as well as a dedicated freight network. I think if you think about Western Australia, or if you think about Sydney, those supply chains have dedicated freight lines, and the wagon kind of just naturally kind of works in that sense, and then it's all about efficiency. But when you think about shared passenger lines, that's where we think the wagon almost presents a solution that we've been looking for. I know one of the challenges with the final part of the Fremantle supply chain here in Western Australia is we do come onto the passenger network, and there's a series of curfews. It's no different to other cities. Those curfews are all about protecting passenger rail and making sure that we never find ourselves in a situation where passenger rail is delayed because of a freight train breaking down or a freight train taking too long to get to speed. These wagons they can, if an individual wagon can do a number of things. First up, it's a lot faster to start and stop and accelerate compared to a longer train, and it can pretty easily kind of slip in behind a passenger train. And can stop behind a passenger train as a passenger train stops at a passenger station. You know, the wagon doesn't mind waiting for those few minutes and then moving along. So we think that the autonomous wagon will actually help solve some of the challenges that we've got with passenger or shared freight and passenger lines. If we're ever going to solve a Melbourne scenario, we think the wagon kind of presents that solution. But then it all comes back to that train control integration and how we kind of manage that capacity that the wagons are taking up.
Okay, thank you. Next one, Rio Tinto's auto haul project took several years to operationalise the system and gain endorsement from the regulator. It was a huge process with so many hazards to mitigate, with several independent safety assessors working to sign off on the system safety as part of the regulator's process. What operationalisation challenges do you foresee in implementing this technology in Australia?
Look, I can go first here, Mary, and then perhaps you can tell the FRA story, which is only ever harder than the ONSA story. Look, we've got a process with ONSA that specifically looking at the roadmap to lead towards commercialisation. ONSA are worried about two things, and these you'd expect both of them. The first is obviously the safety case and how the wagon's perception system works, how quickly the wagon can stop in an emergency type setting when it sees some sort of obstacle. So that's one piece. And then the second is the battery electric power and all of the challenges and all of the concerns that people have around energy sources and managing that from a safety sense. So the way we've kind of structured it with ONDA is to kind of incrementally increase the complexity, and then building out an accreditation strategy that kind of maps to that kind of roadmap that we've got from an ARC perspective. Mary, perhaps you want to tell the story from an FRA side?
Yeah, thanks, Simon. So, we're working through a similar process here in the US with the Federal Railroad Administration, which is our national safety regulator in the US. And, the process is a bit different in the US, where we actually work in partnership with our railroad partners in the US to petition for a test program or a pilot to be able to deploy new technology on the US rail network. And that petition, similar to what we will do with ARC and the work in Australia, basically outlines the operational, procedures that we're going to follow, the safety plans that we'll have in place. But it also identifies, say, the rules and regulations that we don't necessarily comply with because we have very different technology and it's not prescribed in the current rule book. And so we are going through that process at the moment with that petition submitted to the FRA, and we go through an approval process. And so part of that approval process includes, a hazard mitigation plan, safety analysis, a public hearing, a public comment period, where we're soliciting feedback from, all corners of the industry to be able to put together a test and pilot program that, we make sure enables us to have safe operations. We're finding the process in Australia to be quite refreshing because it does seem to be clear and transparent, and process that we can really work together with our partners here towards a solution at the end.
Okay, thank you. There's a lot of questions here, and we won't get through them all. We might, and we should do this for other ones, is publish the questions and the answers. Without traditional couplers, what kind of minimum track curves are the wagons capable of?
That's a great question. We're right now looking at 50 meters.
Okay.
One of the things that we're doing right now as a company, so I talked a little bit about our vehicle generations. We have a prototype vehicle, our second generation vehicle, that we're producing for our initial pilots. And that is one of the vehicles that exists with ARC infrastructure that's, in country. We are also going through a design process right now for our future production vehicle. And so nominally that specification is about 50 meters. We're looking at a pretty tight turning radius. But as we continue to design that vehicle and collect feedback from industry over the next 6 to 9 months, we will then bake that into our future vehicle generation that's available in 2026. So I'll give you a number, but with a caveat there.
Just a general question from me. I'm sure you're not putting sort of a cap or a fence around opportunities, but you wouldn't envisage this running long distance, coast to coast applications, would you?
Yeah. We've always sort of thought that we will never compete well with existing freight rail services. Existing freight rail that hauls, extremely heavy loads over very long distances does a really good job at doing exactly that. We see this solution as highly complementary. We're really going after the markets that rail has always been challenged with because of the necessary economies of scale. And so, when we talk about this port shuttle concept, that's a really great application and use case. We're kind of looking at distances, I'd say like less than 1,000 kilometers, all the way down to that kind of 20, 30 kilometer, port shuttle use case as really where our technology kind of finds its sweet spot. And, ultimately, what we're really here to do is compete with trucks. So we want to get all that freight that's moving by trucks onto rail with this solution.
Yeah, and you're right. It's the sort of last mile that rail has traditionally been challenged with, and even in a place like Sydney with significant rail infrastructure upgrades, my understanding is, the moving containers out of the ports, rail is still the minority provider of services. And so many of these questions are questioning sort of the efficiency between rail and long this concept and long distance rail. So I won't go through them all. Mary, can you tell us anything about other Australian rail market applications where you can see the parallel systems, wagons, and operating technology adding value without the need for major infrastructure investment?
Yeah, why don't I share some thoughts, and then I'll let Simon share as well. So, thinking about these short haul shuttle routes, this is something that Australia does really well. It's not something that we often see in the US. And so, those port shuttle applications, all over the country are, kind of the immediate and obvious use case. But kind of talking about this concept, I talked about in my presentation of expanded line haul pairs. So, freight that is moving between major metropolitan areas that's typically moving by truck, that's a really great place for us to envision using this service because there's existing infrastructure on both ends. So, looking at those kind of regional options between metropolitan areas that have those intermodal terminals that exist. Thinking a little bit about outside the box, we are very focused on the intermodal use case at the moment because these port shuttle applications really support the economics of that business case. As we establish this platform and this technology, we can really expand what we can haul. So we think of these vehicles as a platform. You can put any type of container on top of that platform. And so when we think about maybe use cases that have, a highly disaggregated customer base, agriculture is a great example. You've got kind of widely distributed endpoints and then have a single port that you're bringing those goods to. That may be a fantastic use case for this type of technology as well. And in that case, the infrastructure exists. It's our vehicle body that needs to change. And that's a fairly easy change for us to make from an engineering perspective. So I'll pause there and see if Simon has anything else he wants to add there.
Thanks, Mary. And I need to double down on what you've just said. I think this wagon, the idea of an autonomous wagon works really, really well when there's a disaggregated either origin or destination. The best kind of Australian case, I think, that this lends itself to is the Port Botany supply chain. If you're thinking about the different kind of regional trains that come into inland terminals, trains get broken up and almost positioned into kind of stevedore specific fleets that then run into the 3 rail terminals at port. The idea, if you replace that with the wagons, and if you can imagine the wagons being made up into just a port shuttle, whether it's from Moorebank or Enfield or any of the intermodal terminals in Sydney, that can then fleet as almost a virtual consist along the network in towards Botany, and then just as it comes into the port, all those wagons can split and head off to their individual rail terminals. This is where the idea of the ability of the wagons to move individually by themselves really comes into their own, but yet fleet and kind of work as a virtual consist when they're on the network and utilising capacity.
Okay, thank you. And I must say, Mary, you're very adaptable. You're talking kilometres. Very impressed.
If I'm being honest, I did some Googling before we got on this call and made sure I knew my conversions.
Well, we're a bit ambidextrous here. We mix up our metric and imperial often. What is the axle weight of the wagon current configuration?
Yeah, that's a great question. So I'll talk about our current vehicle and then what we're designing for. So our current vehicles are looking at single stack containers. So our current vehicle is about, the project vehicle that's in Australia is about 40,000 pounds, which going to my conversion is about 18,000 kilograms. The payload capacity we're looking at is about 80,000 pounds. So the max load of an intermodal shipping container, which translates to about 36,000 kilograms. Now, as we're designing this future production vehicle, we're going to have to look at, axle weight and loading capacity. So I'll give you those numbers as a reference point at the moment, but know that will change as we produce our future vehicle.
Okay, and you may have covered this question here. Wonderful concept. ARC network spread across a wide area. Has ARC considered the telecommunications site infrastructure requirements for the project? I guess the question is does it require rail infrastructure network comms, or is it using public comms?
Yeah, so that's a great question, and why initially the concept in the metro is what we've chosen to focus on, where we've got continuous and consistent 4G coverage moving to 5G coverage, which is how the wagon is broadly communicated with. So that works really well in a metro sense. But whoever asked that question knows the infrastructure network well enough to know that as you get out into regional areas, you don't always have that level of connection. So that's when kind of alternative comms solutions need to be developed. We've got satellite backups, and the folks at Parallel Systems many of them used to work for Starlink, for example. So we've got those sorts of backup systems that we're using here in Perth. But in terms of the solution, when we get outside of the mobile zone, is a problem that we need to solve. But for at least for the foreseeable future, we're working based off the 4 and 5G networks. Mira, you can probably talk about the comms piece where you're up to with the wagon.
Yeah, Simon, I think you really covered it right. It's going to depend on the use case. In some cases, we're deploying additional infrastructure on routes. Particularly the one that we're looking in Georgia in the southeast of the U.S. has some very rural parts that are not covered by cell coverage. So, looking at deploying, transmitters along that route, it's, picking up other parts of, the infrastructure. So it's something that we're going to have to look at on a case-by-case basis. We're very fortunate in the Perth area that, we have cell coverage.
Now, innovation is often a two-edged sword, isn't it? Where was this question? Because I thought it was pretty good. How would rail access pricing structures have to change for a vehicle like this to be commercially viable?
Simon, do you want to take that one?
I'm going to give a very, very bland answer to that one, and I could probably almost guess which organisations asked that. Look, and this is where again the train control piece really comes in. Managing the capacity of the infrastructure with the wagons is where the technology needs to work its way through. Are the wagons using individual kind of Parallel guys call them micro warrants or micro blocks? Will you have many wagons inside one kind of traditional block, or will this eventually do we move to like a moving block kind of technology perspective? All of that then kind of goes to capacity, and then kind of it will ultimately take us to pricing. So I'm not going to give a direct answer to that, but I will talk in terms of how we're thinking about it from a capacity perspective, which is what network owners are all about.
And as I said, we've got lots of questions. We won't get through all, perhaps the last one. I guess the traditional wagon standards, P2 forces, those sorts of things for the prototype, was that pretty straightforward, complying with the existing standards, or were there some certain concessions made for it?
Mary, I'm going to give that one to you.
It's a great question. So yes and no. Some things, we can absolutely, comply with, and we've made some changes to the vehicle that we built to bring it to ARC to make sure that we were meeting some of those requirements. Like, for example, red taillights on a vehicle. So we're able to make some of those changes. Some of the changes are not going to, some of the regulations we're not going to be able to comply with, and so We've put operational controls into place to make sure that we're operating a safe vehicle, in absence of those, that compliance. This is still a process that we're working through right now with ARC and ONSR, and we'll continue to work through as we design that future vehicle that will operate on mainline rail.
Look, we'll wrap it up there because, as I say, we do have a lot of questions that we'll circle back and get some answers to. As I said, when I first heard of this, I thought, wow, particularly, and not just an infrastructure owner thinking about above rail operations, literally thinking outside the box. We throw a lot of energy into continuing to refine the traditional rail operating model, and we as an industry obviously need to continue to do that, and in parallel be looking at, well, what are those markets that rail hasn't been in traditionally possibly because of technology limitations, where technology is changing, that perhaps opens up markets. And I'll just finish off this final question, which I think illustrates that. Isn't this a locomotive with a container space, not a wagon that can move? And so, depending how you look at stuff, has an impact on how you deal with the opportunity. So look, Mary, thank you very much, considering the time of the day. And Simon, likewise, thank you for your time. Great subject, a lot of interest. As we say, you guys are trialling it or looking to trial it with that Westport application, but there's a lot of port applications in Australia and no doubt elsewhere that could benefit from this sort of technology. So thank you very much. And just a quick update on the next webinar, Tuesday, the 12th of March, Improving Data Management with Australian Standard 7739.2. which is digital engineering. That'll be presented by Simon Vo. So no doubt the registrations, the invitations have already gone out for that or about to go out, but that'll be another great subject to listen into. Thank you again to Mary and Simon, and thank you everyone for joining in today. As I say, there's some great questions there that it's prompted me to be thinking about, we should be sort of publishing the questions and the answers to each of these webinars. So thanks very much and enjoy the rest of your day.
Thank you, Damien.
Bye.
Thank you.